Today on Inevitable, our guest is Eliot Brooks, CEO and co-founder of Cocoon. Cocoon is enabling the industrial circular economy, starting with a process that helps the steel industry continue to provide a critical feedstock into cement production, one that is increasingly otherwise being disrupted as steelmaking processes move from coal-based blast furnaces to lower-emission electric arc furnaces. Cocoon was built with the realization that as industry decarbonizes, some of the process changes end up disrupting circular supply chain. The link between a slag byproduct of steel and the requirements of cement production is their starting point. Cocoon announced a $5.4 million pre-seed round earlier this year, driven by Wireframe, Gigascale, SOSV, and Celsius Industries. So let's dive in. But first, from MCJ, I'm Cody Sims, and this is Inevitable. Climate change is inevitable. It's already here. But so are the solutions shaping our future. Join us every week to learn from experts and entrepreneurs about the transition of energy and industry. Eliot, welcome to the show.
Great. Thanks for having me. Yeah, really excited to be here today.
Well, I'm excited to learn from you. You're obviously on the early stage of your journey with your new company, but one that is right in the crosshairs of some very large emissions problems as the world continues to build and grow and humans continue to build infrastructure all over the planet. It's an important one. So maybe take a minute to just at the highest of levels describe what Cocoon is and does.
Yeah, well, I think you hit the nail on the head. The world is going to continue to build and grow. Much of that infrastructure is pretty important to the energy transition, to improving quality of life. I don't think anyone sat around saying we shouldn't build more infrastructure. And there's a harsh reality to that infrastructure requires more steel and more cement, more concrete. And so Cocoon is really set out to enable these two industries to decarbonize in sync, having spotted a bit of a challenge in that status quo or the journey for decarbonization of steel is actually in its current form set to have an adverse impact on the cement and concrete industry's ability to decarbonize. So Cocoon is looking to solve that through upcycling industrial byproducts from the steel industry into a material that the cement industry or concrete producers can use.
So I want to hear all about your background and how you decided to build this, but let's pull on that thread you just mentioned first, which is that as steel pursues its own industrial decarbonization pathways, it has a negative impact on how cement gets decarbonized. Can you unpack that for us a little bit, particularly what's going on the steel side that is driving change?
Yeah, for sure. So the path to net zero for steel looks like moving away from the blast furnace, which we know is highly emitting. So roughly 2.2 tons of CO2 per ton of steel produced when you use that blast furnace.
Blast furnace is the heavy coal-based, you think of like big 1950s, 1940s wartime sort of, we have to make steel. It's these giant industrial facilities.
They are pretty big, typically 3 million tons of production capacity per year. And they are highly emitting, as you say, coal-based. So we are moving away from those furnaces and how we manufacture steel. And what we're moving towards is electric arc furnaces. So in particular, across Europe and the US, we are seeing the decommissioning of blast furnaces and replacing them with electric arc furnaces. And as a consequence of that, the byproducts we get from those industries are shifting. So when you make pig iron in the blast furnace, you get blast furnace slag, which is the big byproduct, producing pretty large quantities. And when you either remelt scrap in an electric arc furnace, or you follow a process known as DRI, electric arc furnace, so making steel from a particular type of iron ore that's been treated to get to new steel rather than remelting scrap, you get steel slag. And there has long existed a link between these two industries of steel and cement, or steel and concrete producers, in that the blast furnace slag is processed and treated in such a way that it can replace cement when making concrete. Not fully, but up to anywhere from 30 to 90% in some use cases, you can replace the clinker with blast furnace slag that's been treated.
Let me back you up a little bit. So, with electric arc furnaces, which is what you said a lot of Europe and the US is moving toward, my understanding is most of that steel making is using recycled steel. You're not actually creating the raw materials, taking the iron ore and essentially turning it into the ingredients that make steel. You're taking steel that already exists, you're heating it up and melting it and essentially recasting it, is what a lot of that steel process. Whereas I think in Asia, primarily, a lot of China and India, you're still largely in the heavy blast furnace, which I think is combining iron and limestone. I presume that limestone becomes that core ingredient that gets fed into cement manufacturing. Am I following this correctly?
Yeah, you are. So the challenge is that we need more primary steel. There's not enough scrap. So you can either get to that point by using iron ore, going down the blast furnace route, refining in the basic oxygen furnace, which is the step that takes you from pig iron to steel, or the newer technology and path to net zero for making new steel as opposed to remelting scrap looks at using direct reduced iron ore. So you're treating high grade iron ore so that it can go straight into the electric arc furnace and then produce steel in one single step.
So, as I understand it, then the more traditional means of creating steel using these blast furnaces generates this blast furnace slag, which is used in cement making quite traditionally. But this new, sort of newer electric arc furnace method that is gaining traction in Europe and the US generates a type of a steel slag that cannot be or is not typically used in cement making. And I think you were going on to say that this in and of itself then creates an emissions problem on the cement and concrete side. Am I following correctly?
That's exactly it. So steel slag is pretty inert. Post processing, it's crushed up and used as a low value aggregate. So what that means is as we decarbonize the steel industry, there's less of these, they're called supplementary cementitious materials. So blast furnace slag, and the other one is fly ash. Fly ash comes from coal plants. So the supply of these SEMs that are considered low carbon and can be used to substitute, let's say 50% of cement that goes into concrete, those supply streams are disappearing. And when you look at the net zero journey for cement manufacturers who might grind those SEMs with their cement, or concrete producers who can obviously replace the amount of or reduce the amount of cement they use in concrete, all of them say, point number one, maximize the use of SEMs as much as we can. Now, that's just going to become increasingly harder because we're decarbonizing the steel industry, we're shutting down our coal plants. So the supply of these materials is shrinking and the demand for them is growing. So Cocoon is effectively trying to relink these industries by enabling that steel slag, which is growing in supply. There's 200 million tons of this material produced every year. That number is only set to rapidly increase over the next 30 years as we build more electric arc furnaces, as we start using DRI, EAF. So we're enabling that material to be used and then continue going into both the cement industry and the concrete production process.
How do you enable it to be used? You're having to capture this molten sort of steel stuff coming out of an electric arc furnace somehow and then running a chemical process against it? Is that some part of what you guys do?
Yeah, exactly. So the challenge with steel slag, I mean, there's a few challenges, but the big reason it tends to be inert is because of the high iron content in the steel slag. So you have a lot of FeO. And our process focuses on working with the slag in its molten state to overcome those challenges that the high iron content presents. So there's really two ways you can manage the presence of high iron. You can shift its chemistry, i.e. you can reduce the amount in the slag, or you can overcome the challenges that a high FeO content presents when it comes to forming glass content in the material. So glass content in the material is what drives cementitious reactivity. Iron content is particularly hard to cool very fast, and that is what inhibits the formation of glass content. So you can either cool the material really fast or shift its chemistry, and we're essentially looking at both in the process.
What is a steel slag today used for? This high iron content slag that comes out of an electric arc furnace without Cocoon in the mix, what would happen to it?
It's either being landfilled or increasingly it's finding its way into aggregate. So kind of road filler, inert material, very low value, maybe $10, $15 a ton.
Got it. And so you take it and it sounds like you're running it through a chemical process. Can you explain that?
Yes, for sure. So we look to overcome the high iron content by potentially shifting the molten materials chemistry if we need to. And then we are able to rapidly cool that material to generate glass content. So what's a blessing and a curse is that we have to work with the material in its molten state, which means we have to co-locate with the steel producer, but we're not co-locating next to the furnace. We're operating in their existing slag handling processes. And the reason it's maybe a blessing rather than a curse is that by working with the molten material, the process economics and the process itself and your ability to generate a high performing material are radically improved.
Sounds very complicated working with this material. Let's now jump into your path to building this. How in the world did you come to this space to build in, and how are you developing the expertise to work with all this stuff?
Yeah, it's a very good question. So my background's actually in building and scaling a healthcare company. I founded a company in the UK called Thriver, grew that over the last 7 or so years to good size. And then kind of just as the pandemic started to calm down a bit, had the realization I really wanted to get back to building an early stage startup and to do that in the climate space. So like one of the first resources I went to for that was the MCJ podcast. So thank you very much for that. And realizing that the way we solve the hard problems we face in climate is through hardware, that wasn't where my network was. So I went and joined a venture builder program called Carbon 13, based out of Cambridge in the UK. And it was through there that I met my 2 co-founders, Dr. William Knapp and Freddie Scott. And Will's PhD research had focused on looking at these new emerging industrial waste streams and how you might valorize them in different ways. So really we have a starting point there of some potentially interesting ideas of what we could do with that material, how we could valorize it. It was not a fully developed piece of IP or technology yet. We had to go then build all of that. But I got super interested by these trends in terms of, yes, we're going to build a huge amount more. Yes, that means more steel, more cement, but also how these net zero journeys of these 2 industries were at conflict with each other. And the more we spent time researching the idea, looking into the industries, the higher the conviction built in the importance of what we're doing. I think the other aspect there is that our time to impact can be very quick in decarbonizing the concrete and the cement industry, because you are already producing 200 million tons of this material. It's a case of carrying out this process and getting it into market as quick as possible. There's already a very clear value chain for blast furnace slag that we can learn from. And it's just a case of scaling. I say just a case. It's a case of getting the tech to work and then putting it into every electric arc furnace there is. That time to impact, I think, really drew all of us in.
It strikes me that these steel producers, I would presume, are not taking a blast furnace facility and changing it or converting it to an electric arc furnace facility. These are probably separate locations. You eventually decommission your blast furnace facility. You build your electric arc furnace facility, maybe somewhere else. And as such, their own sort of sales processes and supply chains inside their facilities may already be tuned to certain workflows. And so if you run a blast furnace steel production facility, yes, you maybe have already a buyer that is a cement factory nearby that is taking your blast furnace ash or fly ash and using it for something. But if you're running an electric arc furnace, you maybe don't ever even have that sort of supply chain workflow as part of your facility at all today. Is that a fair assumption? And you're having to introduce new workflows to some of these facilities, or is that a false assumption on my end?
I wouldn't say it's completely false, but what you do have is this material already being used as aggregate. So those supply chains already exist. And actually, for lots of historic reasons, blast furnaces tend to be very concentrated in regions where you can get ports and import the iron ore. Whereas electric arc furnaces are a lot better distributed in the same way that cement plants are a lot better distributed over geographies because of the abundance of limestone. And you're not going to transport cement huge distances. So the ability of electric arc furnaces, if we can process this material to then supply the cement industry, is far greater. The coverage they provide within to that industry is a lot better. And you'll often find already those transport links in existence.
Hey everyone, I'm Yin, a partner at MCJ, here to take a quick minute to tell you about the MCJ Collective membership. Globally, startups are rewriting industries to be cleaner, more profitable, and more secure. And at MCJ, we recognize that a rapidly changing business landscape requires a workforce that can adapt. MCJ Collective is a vetted member network for tech and industry leaders who are building, working for, or advising on solutions that can address the transition of energy and industry. MCJ Collective connects members with one another, with MCJ's portfolio, and our broader network. We do this through a powerful member hub, timely introductions, curated events, and a unique talent matchmaking system and opportunities to learn from peers and podcast guests. We started in 2019 and have grown to thousands of members globally. If you want to learn more, head over to mcj.vc and click the membership tab at the top. Thanks, and enjoy the rest of the show.
And do you have a role to play in selling to the cement manufacturers, or do you leave that in the hands of the steel facility and you're just helping them create the byproduct they need or can sell?
So we're developing the product and selling it. That's really the expertise in the company, is understanding what makes a great SEM, how we drive and continuously improve the performance of that material. And it's not something that the steel producer, their core competency is making steel. This is just a byproduct that's, quite frankly, often an inconvenience for them. So they don't want to invest time and energy in looking how to utilize that. They're happy for someone else to come in and do that.
So to some extent, then you have a little bit of a two-sided sale. First, you need to sell to the steel facility, the electric arc furnace facility, and say, hey, let us co-locate on your property. We're going to transform your waste product into something that will generate more value for you. And then you have to turn around and go to the cement facility and say, buy from us. It's really chemically equivalent to all this stuff you've already been buying. Trust us, run some tests, and the requisite pilots and demos and all that stuff you're probably going to have to do to make your initial sale. Am I correct in those assumptions?
Absolutely correct. And when you say it out loud, it sounds really difficult, but I think we...
Hey, startups are hard. Startups are hard.
They really are. But we benefit from the fact that this is already done. Our business model is really simple. We want to enable the exact same value chain to exist as does for blast furnace slag. And we know how the value accrues in that slag throughout the process. And we know the end sale price, the point at which it's ground, what the price is, the point at which it's granulated. So that's the post-processing of blast furnace slag you have to do to get it cementitious. And we know what the steel producer is earning per ton for their molten slag. So whilst making a market and matching the feedstock with the customer is a little tricky, it's been done before. So everyone's familiar with what can exist and can happen.
And so if you are producing and selling the product, I assume then you finance and own the facilities, and you're just rev sharing on both sides of your customer base. Is that correct?
Yeah, exactly. So we want to own, the ingoing assumption is that we will own and operate these facilities. And I think one of the, again, back to the benefits of working with molten slag and the particular model we pursued, is it's relatively CapEx light in comparison with setting up an entirely new facility, maybe developing a novel ordinary Portland cement, because we have this material already there. We have the transport links, we have the logistics, the infrastructure. We're just saying, put a Cocoon unit on your plant, let us process that slag. It then needs to be ground a bit further, and then it's good to go.
And I said rev share, but that's probably inaccurate. You're buying the slag and you're selling the, essentially, I don't know the word, the blast equivalent slag back out.
You're right. We give a rev share to the steel plant. That's what we're pushing for. And then we sell the product into either cement plants who will grind it with cement to make a slag cement, or direct into concrete producers who will use it at the point of making concrete to replace up to 50% of cement in that concrete mix.
Now, if I'm a steel producer today, I'm having to weigh lots of different choices, right? I might be migrating to an electric arc furnace or operating electric arc furnaces, and I'm trying to figure out how I'm going to procure the clean energy I need to run this. It requires electricity to run these furnaces, I think, most of which today is, I presume, gas powered, but they may be buying power off the grid. I don't know. But it seems like hydrogen may play a role in this in the future in many people's minds. It seems like using natural gas and using point source capture may be a role to play. How are these steel facilities thinking about the evolution of their decarbonization journey?
So it depends a little between geographies. So in the US, 70+% of steel produced here is done via the electric arc furnace. So they're pretty used to the economics. It is typically powered with grid electricity.
So they're just powered on the grid and maybe in the future might be buying PPAs and whatnot to help with the energy need they have.
Exactly. And then in Europe, they're evaluating these CapEx decisions. Do we reline a blast furnace and give it another 10, 15, 20 years? Or do we move over now to an electric arc furnace? They're looking at, a lot more sensitivities perhaps than they might have had with a blast furnace in terms of the electricity price, which varies quite a lot in Europe, the cost of scrap, which is likely to go up as we build more of these electric arc furnaces versus iron ore, which is probably going to be a bit more stable. The capital decisions are a lot more price sensitive. And I think that's really where Cocoon can play a role in increasing the adoption of these low carbon technologies like electric arc furnaces, is we can help limit the sensitivities by bringing in additional revenue to that producer.
Sounds like I was largely incorrect in saying that these would be natural gas powered in the future. They're, at least in the US, mostly just plugging into the grid today and leveraging the power of the grid, which might be natural gas based. They're not doing on-prem power generation necessarily.
They are sometimes using natural gas as well to get up to temperature.
Talk a bit today about where you all are from a tech readiness perspective, from a deployment perspective. What's the near-term path for you?
Yeah, so we've proven we can make a material that performs pretty close to GGBFS and definitely better than, so GGBFS being ground granulated blast furnace slag, and definitely better than fly ash. And now we're scaling the technology. So we have a series of larger scale melts happening at a research and development steel plant that's going to give us the hundreds of kilograms we need to put this material into concrete, get use cases done, and start showing the performance of the material over the longer term. And we also have one agreement in place to carry out an on-site trial with a steel producer where we'll actually be bringing that unit on-site, running it for a period of time, and again, generating more like tons quantity of material that we can give to potential off-takers. So that's really the big focus over the next 6 months, is scaling up the technology, proving it in the relevant environments, so TRL6, with a view to then securing the buy-in we need from off-takers and the steel plants to build a pilot plant.
How are you building the necessary industrial expertise on your team to be able to, in parallel, have conversations with the steel manufacturers and with the cement manufacturers? That's a lot of legacy industrial knowledge to bring to bear and to walk into a room and essentially be credible and not be this hotshot startup trying to tell them how you're going to change everything they do.
It's definitely a challenge. So we've got some great advisors on board on both the steel and cement side, people who have 20, 30 odd years in each of those industries, respectively, in C-level positions. So they've been incredibly valuable. I think that there's also value in being an outsider into this industry coming into it. Now, you need to toe that line really carefully, but being the external innovator coming to the industry, if you've got the right advice around you, where folks who really understand those industries as well, it can play out to your benefit. And that's something I found with my previous startup as well, where 3 founders in the team had no healthcare experience, but we came at it from a patient lens of how we wanted that experience to be. And likewise with Cocoon, we're really thinking about how can we go as fast as possible in a safe way and build safe tech, but how can we leverage existing equipment off the shelf where possible? How can we deploy technology in a way that we can really get this product to market as fast as possible? And that outside influence can be a really powerful thing.
And from a decarbonization perspective, you don't really need to sell decarbonization to the steel industry. You're leveraging existing movement in the industry already to these electric arc furnaces and working with steel producers who already are doing that. And then I guess on the cement side, you're really also not necessarily selling decarbonization. You're selling access to supply, presumably in a supply chain constrained space for them where there's less and less of the raw material that they need. And you, I guess, are going to just have to make sure you can hit quality and hit price points.
That's exactly it. I mean, that's the business model, is enabling a value chain to exist that already exists elsewhere. We want to produce a product that performs comparatively to ground granulated blast furnace slag, that is priced comparatively, and there is clear path to hundreds of thousands of tons per year per site. So when you speak to the cement and concrete industry, one of the first things they're asking, particularly with SEMs, but with other alternatives to clinker, is how does this get to 100,000 tons? And I think for us, the benefit of our approach, although there's lots of complexities, is that the material is already being produced in that quantity. So it's just a case of putting it through the process.
Any geography that is a clearer path to market for you, particularly thinking of Europe versus the US?
So the US is definitely the priority right now, given that 70% of steel here is produced by the electric arc furnace. And therefore, there's a lot more steel slag, but also on the concrete side, the standards and cement side, the standards are a bit clearer in terms of how you bring the new product to market. So you have performance-based standards here, whereas in the UK and Europe, they're changing and there's new standards coming out or out already, but they're relatively new. So the kind of market acceptance still needs to be built, but they historically have had recipe-based standards. So there's a standard for blast furnace slag, and the only thing that would stop us meeting it is it specifically says in the standard blast furnace as the source for the slag. So those markets are changing and updating their standards, and there is more steel production gradually shifting over to electric arc furnaces. In the UK, they've just decommissioned 2 blast furnaces in Wales. Those will be flipping over to electric arc furnaces. In Europe, you have DRI electric arc furnace plants being produced. So that's very much the kind of next market after the US. And there's a really interesting piece here as well, is as we switch to DRI EAF, the yield of slag per ton of steel jumps up. So you produce a lot more slag as a consequence of using that direct reduced iron ore in the furnace.
I was going to ask what DRI means. Okay, direct reduced iron ore. Can you explain that a little bit?
Yeah, so that's effectively how you get certain types of high-grade iron ore and process them in such a way that they can then go into the electric arc furnace, and you go straight from an ore into steel.
As opposed to recycled steel.
Yes, exactly.
Obviously, the U.S. steel industry has been in the news recently with U.S. Steel navigating a potential acquisition by a Japanese company. And then I think really the only top 10 or 12 sort of global steel producer in the US today is Nucor. Is that the right way to think about the industry and some of the powers that be here? How much of steel manufacturing is driven by these large companies that you may have heard of, and how much of it are smaller, independent producers?
So you're right in that a lot of steel is not produced in the US. So 60% of steel roughly is produced out of China, a lot out of India as well. But I think importantly, steel is being seen as a resource of national importance, particularly in the US. Kind of onshoring manufacturing is becoming a thing that we're seeing globally. So we really do anticipate that there's going to be lots of steel slag from lots of great partners, both in the US and Europe, to work with.
You guys just announced a fundraising round earlier this year. Explain a little bit about that and how you plan to deploy the capital that you brought in.
Yep, so we closed the round in May 2024, which now seems like a bit of a lifetime ago, and that's the way startups go, I guess. But we had some great investors, so Gigascale, SOSV, Wireframe, and Celsius Industries coming into the round. And we have been building an R&D facility. So most of the team's in London, where we've built an R&D facility from scratch, kitted out a really great space in about 2 months that's enabled us to drastically improve the product, scale the technology. Then a lot of the capital has obviously gone on growing the team and then getting these trials and scaling the tech ready for the trials happening from this month onwards, and then on site from the middle of 2025.
And you said that the US market is your primary focus. Do you expect your initial demo plant to be in the UK, or are you trying to get it co-located in the US somewhere?
It would be co-located in the US. Yeah.
Eliot, what else should we have talked about? We've covered a lot.
What really drives us at Cocoon is time to impact. And, a ton of CO2 avoided today is better than a ton of CO2 avoided tomorrow. And I think that the exciting thing about what we're doing is, yes, this material exists already. It's a common business model. It's well understood. But also, we really want to be the fastest moving hardware company out there. And I think we're doing a good job so far. We started the company with just an idea in May 2023, closed our big major round in $5 million round in May 2024, and now at the point of having on-site trials happening in 2025. And I think that a lot of what drives that is having a really good mix of team from different industries who are bringing learnings from the academic, the science world, how you do rapid prototyping and engineering, how you can think about getting products to market faster and overcoming the kind of long challenges with scaling technology through the TRL levels, and then bringing folks from other sectors who have worked in startups, worked in scale-ups, and seen the pace, be it from the software side even. I guess I would just really encourage other people who might be sat on the sidelines thinking the world is burning, but I don't really know what part I can play. I think you really can, and you shouldn't underestimate what you've learned from other industries in terms of how you can help tackle the climate emergency.
I'm hearing you say don't be afraid of steel and cement sounding foreign to you. If you come from technology or you come from hardware, don't be afraid to put your hand up and jump in and learn the industries.
That's certainly the case. I mean, there's a steep learning curve, somewhat slightly crazy decision to do it in many ways, but it's been a great one so far. And yeah, I think if you apply yourself, you can pick things up relatively quickly. And if you get around you the right advisors and people, that makes that journey a bit easier.
Well, Eliot, I think what's really fascinating to me about what you're building is the idea that we think of the circular economy as often this, how do we recycle the things that we use in our everyday life? But there's certainly a big aspect of circularity that frankly already happens in a lot of the world today. Companies want to use as cheap of materials as possible, and using waste from one industry to be a feedstock for another is just the way the world works today. But as we transition and try to move technologies from one way of producing them to another, those feedstocks may get interrupted as a result of it. And it seems like you've put your thumb on a problem here where the steel industry actually transitioning to a lower emissions process is disrupting the supply chains and the circularity of how industrial products are made. And you're trying to solve that.
Exactly. I mean, that's basically the mission of Cocoon, is understanding where circularity breaks in the energy transition and then developing products, services, technology to help solve that. And hopefully the Cocoon unit for upcycling steel slag is the first one of many technology initiatives that we'll do to continue enabling that circularity.
What do you think might be beyond this one?
That's a very good question. I don't have the answer to that. I can say that the problems that we've identified in the steel industry, you will find in other heavy industry settings, mining, for example, and we will see in time. I don't have the answer on me right now. Too busy focusing on Cocoon.
Where did the name Cocoon come from?
My co-founder came up with it, and double meaning of the OCO, so CO2, in the name, as well as the idea of taking something, a cocoon, transforming into something a lot more valuable or beautiful, dare I say, possibly insulting. Well, actually, this is a funny point in that we realized afterwards that moths come from cocoons, not butterflies. A caterpillar goes into a chrysalis to form a butterfly. Not sure moth is quite as good an analogy for what we're making as a butterfly might be.
There are some very beautiful moths out there, I'm sure.
Probably insulting some moth fans out there.
Eliot, this has been a blast, to use one of your frequently used words. I appreciate you making the time and can't wait to follow along with your journey.
Awesome. Thank you so much for having me, and look forward to listening to future podcasts.
Inevitable is an MCJ podcast. At MCJ, we back founders driving the transition of energy and industry and solving the inevitable impacts of climate change. If you'd like to learn more about MCJ, visit us at mcj.vc and subscribe to our weekly newsletter at newsletter.mcj.vc. Thanks, and see you next episode.